Hey guys, welcome to the third lesson on advanced C# programming. Today we're going to be talking about what is the difference between value types and reference types. This video is actually inspired from when I was recording a video for the certification videos on C#, exam 70-43. The current one I was up to, it was starting to talk about what's the difference between value types and reference types, and I thought, well, this video is not long enough to really explain this and bring this point home. So that's what I want to do with this. I want to create a video separately just for what's the differences between a value type and a reference type in specifically C#. Because once you can understand this, it really helps you understanding programming in general. I'm also, at the end of this lesson, after I talk about the basic concepts of value types and reference types, I want to show you what memory sort of looks like for both of these types. So I'm going to talk about the stack and the heap and what memory looks like. Okay, so let's start off by talking about what are some examples of some value types and what are some examples of reference types. Well, off the top of our heads, when the things that we've been using already, things like integers and doubles, bools and things like that, those are value types, and they're value types because they're defined as structures. A structure or struct, you can make a struct, is by default a value type, and to prove this, if I just go int and I right click on that and hit go to definition, we can see that the int, this is the basic outline of the code for an int. You can't see the code because it's a DLL, so they're protecting it. But you can see that int32, or int, is a struct. So a struct is a basic value type. If you want to define your own type of custom value type, you can make a struct. Now, a basic reference type are classes. And we worked with classes throughout all our code. And if you're watching this video, you probably know what classes are. So I'm going to assume you know what classes are. So a class is a reference type. And in the previous videos, we made examples of this by creating student classes and employee classes and things like that. So that's the two general. You could think of, in general speak, structs are value types and classes are reference types. But now, what are the differences between them? So before I start showing you some code and how we can prove the differences, I want to just draw a diagram for you, a very basic diagram, and then we'll go into more detail and more detailed diagrams. Let me get paint over here. So when I was learning programming, the diagrams like this really helped me. That's why I'm going to show you them now, because they really bring home the point of what it looks like kind of behind the scenes. So I want to have two examples. I want to have an example for this is what a value type looks like over here, and then I want to do what a reference type looks like over here. So that's what we're going to do. So on the left hand side, a value type. So let's go ahead and I'm going to draw this box right here. So let's say in code I did this declaration. Let's say I did int x equals 5, like that. So what does that look like behind the scenes as a value type? This isn't exactly memory yet. I'll get to memory towards the end of the video. But what is int x equals 5? What does that look like for us? So this is what it looks like. I'm going to draw a line. So in my diagrams, what I'm going to do is on the top is the name of the variable, and on the bottom of the line, it's the data, what is stored in that variable. So on the top of this, what do we get? Well, we get an x. That's the name of the variable, so an x goes there. This is what it looks like behind the scenes. And for a value type, what do we get in the data portion? We get, well, in this case, we get a 5 because our int x equals 5, so 5 gets stored in the data portion, and x gets stored in the name portion. So this is int x equals 5. This is what it looks like in memory, or not in memory yet, but this is what it looks like kind of behind the scenes. Logically, you can think of it like this. Now, a reference type. What does a reference type look like? Okay, so this gets a little bit different. Let's say we had a declaration like this. Student S equals new. Actually, let's start with student S, right? Let's say we had student S. Student Let's say student consists of an ID and a name. That's it. An ID is an integer, a name is a string. That's what a student consists of. So, but before we even do that, we just have student S. Okay? So, what does that look like? So, that looks like very similar to the int x. So, we start off with a box, and we get a name in the data portion. The name is simply S. And the data, what is the data right now? Well, in a reference type, if you have nothing equal to reference type, by default, it's going to go to null. So we're going to see this kind of null here. So these are the two pictures right now. So int x equals 5, like that. Student S, S, and then null. Okay, let's change this. Let's say, what's the best way to do this? Let's go like this. Let's just get rid of this. Alright, let's change our declaration. Let's say our declaration now is student S equals new student. That's my declaration. So what does this look like now behind the scenes? Let's get rid of this. What does student S equals new student look like? Well, this is what that looks like. This new student part, because it's a reference type, that new, when you say new, you're allocating new memory. More specifically, you're allocating memory on the heap, and that's what we'll talk about in a second. So we get this new box. This is what happens when we say new student, when we're declaring a reference type. But what do we get inside of the reference, inside the data part? We get this picture. We get an arrow that points to this. Okay, so yeah, this is the picture that we get. We get our variable, and it points to our data. Now, however, what does our student consist of? Our student consists of an ID and a name. So that's what's stored here. That ID, the name, would be stored here if there was any. But the picture, what we get is we get our variable and its data portion. This data portion is not a value. Like for a value type, that's where it gets its name. The data portion of a value type is a value. It's 5, as you can see right here. But the data portion for a reference type is a pointer, you can think of. Even though if you're coming from C++, you could think of it as a pointer. The data portion of a reference type points somewhere else. Now, why would we want to do something like this? Now, there's many reasons. But let's say, for example, we wanted to create another student. So let's say we created another student over here. And let's say the declaration for this was student S1 equals S. What does this picture look like now? I created a new student. I did not call new. There's no call to new, so no new memory is allocated on the heap. So what happens? I'm saying student S1 equals S. So what the picture looks like, and I'll show you what this looks like for a value type here in a second. This is what this picture looks like. It goes like this. My name is S1 here, and my value, my data, looks like this. Boom. It points to the same memory location as this one. That's the power of reference types. I can pass the reference because when you do an assignment, right? Any assignment with the equal sign, it takes the value of on the right and stores it in the value on the left. The value of S is right here. This is the value of S. It's a pointer. The value of S is pointing to something else. So I'm pretty much just passing that pointer to the other one. Now, you can think of this when I get to memory. You can think of S holding right here, like right here, the data portion of S. You can think of it as holding a memory location, and I'll show you that. So I'm really just passing the memory location to S1. So now they're both pointing at the same place. Now, this differs with the value type. So let me show you an assignment with a value type over here. Let me do this in black. So a value type. Let's say we had another declaration like this. Let's say this time we did int y equals x. So what does that look like? Well, this is the same thing. What happens with this is it just dumps the value of x into y. So what does that mean? We got this kind of picture. Y, and then the value of y will be 5. That's what happens with this statement. So with a value type int x equals 5, you get x and 5. Int y equals x, you get y, and then 5 just gets copied over. This 5 just gets dumped into there. That's all the assignment does, but it's a little bit different with reference types. With a reference type, we get student s equals new student. We get the s variable, and the data portion of the student is a pointer to memory that's located somewhere else that holds the ID and name. So if I go student s1 equals s, instead of just dumping the value 5 in there, which it does do, we get the logical picture of it pointing to the same memory location. So that's what we get there. Okay, so this is the basic picture of a value type and a reference type. Now I'm going to do a couple examples in code to try to bring this point home. So let's start off with value types. Alright, let's start with a basic example. Let's say we have int x equals 5, like we did, and then int y equals x. So when I have this declaration right here and these variables, if I change the value of y, I say now y is equal to 10. Well, I said y equals x, and now y equals 10. Does this change the value of x? I don't know. Let's see. Let's go console.writeLine and pass in y. So I said y is equal to x, but x is a value type. Remember, x is just a value. So now y equals x, and then y equals 10. Does that change the value of x? Let's run that. And as we see, oops, wow, what the heck? I'm supposed to be displaying x. Okay, so console.writeLine x. So is the value of x 10 or 5? And as you can see, the value of x is 5 because these are value types. Now let's change this. Let's use a function now to show this point. Let's go static void change, and it takes in an int, and all it does is it goes x equals 500. So whatever value is passed in, it just changes it to 500. So if I had int x equals 5 here, and I go change x, so I'm changing the value of x, and then let's display the value of x. Let's go console.writeLine x. What is the value of x going to be? I'm passing x into my function, and then I'm modifying x in here. So shouldn't x in here be 500 also, or would it be 5? Let's see. As you can see, it's 5. And the reason why it's 5 relates back to the picture that I showed you guys. Since x is a value type, I'm passing in the value of x to the function. So I'm simply just passing in 5 to this change function. When 5 comes in, it gets allocated to this new variable, int x, that's specific to change, and then I change that variable to 500. In this meantime, it's not affecting x here it's not affecting it whatsoever because I'm just passing in the value. With a reference type, however, I'm passing in the reference, or where the memory location is. So if I modify the memory location and change, then I'll see the change in both places, and I'll show you what that is right now. So that's this example. Let's go ahead and create a student class so we can just see what this looks like. So I'm just going to go add new class, student. Let's create a student class, and we're just going to have two public variables. I'm going to say public int ID and public string name. That's it. So int ID and name. Let's go ahead and create a student. S equals new student. Let's go s.id equals 5 and s.name equals Bob. So we have this. Let's make our function now. Let's make our function take in a student s. And when I change it, I'm going to change its ID to 10 and its name to Frank. Oops. S.name. So that's what I'm doing. The change function now changes my student's name and ID. And when it gets back, actually I need to call change. I'm going to say change s. And then I'm going to display the values of my stuff. I'm going to say console.writeLine s.id and s.name. So this is the same exact example that we had before with the reference type. The value type. Now we're using a reference type. So you have student S equals new student. We set it 5 Bob. We change S, and then we display them back. So what happens? Do you think that the change is going to be seen inside of main? Whatever changes I make into here will affect this. And the answer is yes. So let's go ahead and run this and look at the output we get. We get 10 and Frank. So that the values that we changed inside of the change function affected the values inside of main. Now, why is that? Let's look at the picture again. The reason why that's happening is because when I pass my function, or when I pass my variable to change, I'm passing whatever is stored in the data portion. Remember with the value types, I pass whatever is stored inside of the data portion. The data portion is right here. So whatever is stored, it was a 5. So I'm passing just the 5. But with a reference type, I'm passing what is stored in the data portion. What's stored in here? It's a pointer or a memory location to this. It's pointing to this. So I'm passing the how to access this pretty much. So the method, when I pass in this memory location right here, the method knows how to access this ID and name. So that's what's happening. I'm passing in how to access it. So when I access it right here, I'm accessing the same memory location that's being accessed right here. So that's why I get that change. That's the difference between value types and reference types. Now, I hope this didn't confuse you more than before you started. I'm really trying to explain the differences between it. And I really think this picture, you should screenshot this picture. This picture is really important in understanding the differences between a value type and a reference type. The value type and the reference type points to the other memory location, where the value type has the memory right at it. You can think of it that way. So that's the differences between that, and we start a little bit with code. Now, I want to break down the memory now. So this is more advanced. If you're okay with this, stop the video now and don't worry about what I'm going to say now. But now I want to get into memory and what does the memory look like behind the scenes. So let's go back to our paint and start over. Let's start talking about memory. So inside of C# in most programming languages, we have 2 types of memory locations. We have, so let me go ahead and draw these. These are like 2 big arrays you can think of. So our first memory location that we have is called the stack. And our second memory location is called the heap. Now, each of these allocate and deal with memory in different ways. Now, this is going to be a very basic introduction. I'm not going to go into this too much because you could talk a lot about this. But, yeah, both of them get allocated in 2 different ways. So let's say we are inside of main, and let's say we have our statements over here. And what does it look like in memory? So these are our statements that are going to go over here. So what does it look like in memory? So let's make our first statement inside of main. Int x equals 5. What does that look like? So before I can do that, I'm going to start dividing up my stack and my heap. So my stack, let me move over a little bit. Okay. So my stack, let's divide this. Let's divide this up a little bit. Okay, so I did some dividing up of my stack. So in memory, everything has a memory location. Now, these are not how it really works. They're hexadecimal locations, but I'm going to say, okay, this is location 1000. This is location 1004, 1008, 1012, 1016, and let's just leave it with that right now. So these are some memory locations that we have on the stack. So the declaration int x equals 5, what does that look like on the stack? Well, it looks like this. It goes into here, so let's put the value right here. So 5 would be stored right there. And then over here, it's going to be like, it's an integer, and it's called x. So in memory, this is what it looks like. The stack, now on the stack, it has a 5 and an int x. That's what that statement looks like. Let's do another statement. Let's say we do int y equals 6. In memory, that looks like this. 6 int y. So that's what that looks like. Now, if I did an assignment, let's do one more. Let's see if I did int z equals y. Simply, this is what that looks like. Since these are value types, 6 int z. So that's what that looks like. It takes the value of whatever's stored in y, allocates the memory on the stack, and then we get our little information. It's an int and a z. So that's the basics with the stack. So if you have anything that's a value type, if you define a value type inside of main, it's going to be allocated on the stack like this. Now let's get into a little bit more with reference types. This gets tricky with reference types. So I'm going to do a few examples with this. Let's say I had student s equals new student. So what does that look like in memory? The new portion. Remember when I was doing the diagrams before, I said, oh, there's other memory locations somewhere else. Well, that other memory location is the heap. The heap is where the extra memory is stored. So what does student s equals new student look like? Well, this is what it looks like. On the stack, what do we get? For our, so maybe go ahead like this. So I'm going to leave the data empty right now. Well, we're going to have student, comma, s. That's what that looks like. So that's what that looks like. This portion right here, we have student s. But what is the value? Well, that gets determined with the heap, because the new allocates new memory on the heap. So let's go ahead and divide up our heap memory. So this is what this looks like. This is how the picture of a pointer comes to be, and you'll see right now. This is what happens in memory. So let's give our heap some memory locations. Let's say this is 2000, 2004, let's just say hypothetically, 2008. These are representing our memory locations, and remember, once again, this is not what it really looks like in memory. They're hexadecimal locations. 2012 and 2016. So okay, so now let's finish up the student. So the student allocates new memory on the heap. That's why we got that separate block, and that's why variables can reference the same memory, because it's on the heap like that. So on the heap, what does it look like? Okay, well, student s consists of what? An ID and a name. So let's say, hypothetically, let's make some two statements. Let's go. s.id equals 5 and s.name equals Bob. So that's what I did with my student. So what does that look like? So on the heap, we get this 5 right there, and we get this int id, and then we also get this. We also get Bob, and we get string name. String name. Hold on, let me fix this. So that's what that looks like on memory. But we're missing one thing. So on the heap, that's what happens on the heap. But we're missing how on the stack, our student variable, that's not referencing that yet. So how do we reference it? Well, how we do it is, in its value portion, it holds the address of the starting location of the memory of that class or whatever it is. So this is holding a 2000, and 2000 refers to the integer. That's the starting location of the class on the heap. So that's how we reference it. So now student s is referencing the memory location on the heap. Okay, well, let's say we did another statement. Let's say we did student s1 equals s. What happens? What's the picture like this? Well, this is how we refer to the same location. So let's go. Let's define the type. Let's go. It's gonna be student s1. So that's that. But what's in the value? What's stored in the value? And if you wanted to refer to the same location, It's just the same location is stored. Come on. So that's what that looks like. So now these both refer to the same location because that 2000, they both hold the 2000, which is the memory location for their data. And this is the reason why when I pass a reference type to a function, they both modify the same location, because what's being passed to the function? The 2000 is. The memory location is what is being passed to that function. And that's what's being modified. So it's modifying the memory location data. And these two things have the same memory location data. So that's why we get the change everywhere. But with value types, we're just passing in the value. It doesn't point to anywhere in memory. Look, for int x, the memory location is 1000, but I'm passing in a 5 to the function. So it's just modifying that 5 and not the actual memory location. Now, I could pass in the memory location if I wanted to, and that's using the ref and out keywords. I think I do some of that on my fundamental videos, but that's what that happens there. But overall, the reason why reference types can be modified is because you're passing the memory location. See the 2000? That's the memory location on the heap. That's not the actual value of it. The values of student are Bob and 5, but I'm passing in the memory location. So that's the basics of memory in C#. We have the stack and the heap. Now, the heap, just a note real quick before I end this video. The heap, the memory on the heap is managed differently than the memory on the stack. The stack memory is managed automatically, and the memory on the stack gets deleted when things go out of scope, for the most part. The memory on the heap, however, gets managed by the garbage collector. The memory on the heap is, the garbage collector comes in and says, is anything referring to this memory 2000 location? If there isn't anything referring to it, then the garbage collector will delete it. But if there is, it will leave it intact. This differs from C++. So if you're coming from C++, and I will be talking about this in my C++ fundamentals probably, if you're coming from C++, you have to manage heap memory yourself. In C++, you have to call delete, and you have to free the memory location once you declare that, oh, I'm done with this memory. I have to release that memory. So that's the difference between C++ and C# and Java, for example. C# and Java both have garbage collectors, so they'll manage the heap memory by itself. But in C++, anything that you declare on the heap, you have to manage. And if you don't manage it, you'll get memory leaks. So that's the difference between C++ and C#, and the difference between the stack and the heap, and the difference between reference types and value types. So, if you guys want to see more in this, if you think this is interesting, leave me a comment and I will maybe go into more detail with this. But for the most part, this is the basics of reference types and value types and stack and heap. So, I hope you guys enjoyed this video, and if you liked it, give me a thumbs up and subscribe, and I'll see you in the next video.